Good morning and welcome to the CADclass podcast. I'm Josh.
I'm Jake.
And we're here to talk about all things making and 3D printing and news. We got some news coming out. We've got some Prusa announcements. We've got some things.
CAD,
And we've
projects, alliances, so many things.
So
Good God,
many.
It's been a busy week. And do you know why I know that it's been a busy week?
I do
Is
not.
because I've been going to sleep at 1 a.m. and waking up at 10.
You are a madman. You've also been waking up at 4 a.m. and I think you were pulling like 17-hour days.
Yeah.
So, and why, Jake, are you pulling 17-hour days? That's what I gotta know.
Because we decided to write a new book every single year. That's why, Josh. That's why. We had
the how hard could it be?
That is okay. I think that phrase, how hard can it be, is one of the banes of my existence. Like, that has caused me accidentally to do so many things that I just shouldn't have done. Like, okay, I immediately a tangent. I'm gonna start. So when I was doing my my senior thesis when I was in engineering school, the whole idea of an engineering senior thesis is that it's either a product or a new technology, or you work with an existing company and they say, hey, we have this idea and we want someone to test it out, but we want it to be really cheap. So senior thesis are just you showing off you can go through the whole engineering and manufacturing process of something and showcase a result, and it has to work. And if it doesn't work, you literally have to stay another semester until it works. And the whole point of it is to showcase what you know. So if you do a really big, fantastic project, then great. Then employees can see that you can kind of manage big projects. And you kind of fed this idea for years. And so years before my senior, I was just thinking like, oh, what are some huge, big projects I could think of? And I got really obsessed with The Martian during that time, the Andy Weir book and the Matt Damon film. And I'm like, oh, global dust storms that block out the sun. Well, that kind of means solar panels won't really work. So you need to have a backup energy supply. And so just on the whim, going, if I had to make an engine on another planet, what would it look like? Well, it can't run off a combustion because there's no oxygen in the atmosphere. The resources have to be on that planet. It has to be this, has to be that. And it just very, very casually in my head as a freshman in engineering school going, I'd probably build it out of like thermites because there's so much rust on the surface. That's a cool idea. All right, let me go to class. Do. And then proposing that to my group, like, we should make an engine on Mars. And they went, that's the stupidest thing ever. And I'm like, how? And I remember saying, how hard can it actually be? I remember saying that in a parking lot at 10 at night after our lecture, and all of them just looked at me like, you're an idiot. You're a complete idiot.
Too hard.
And turns out, yeah, I was an idiot. It does work. It doesn't work that well. But
well, maybe it could work well, but
it could work well.
To be tested, to be continued. But really quickly here, so good morning, Cadence, Sam, Ogre, Cornelia, PC Van Fleet, Johnny Yurda fan. Nice to have you all here.
What's up, everyone?
Thanks for saying hello. Hello.
All right, Josh. So we have got actually Chock-a-Block week. I kind of want to start off on the I made a thing because we didn't get to do it last week.
Yes,
and I did see a couple of
reads, and we have a comment in here too, which is going to be about one of the things on the I made a thing. So we will address that as soon as you get to it.
Fantastic. All right.
Yes.
Let me go ahead and share my screen. Oh yes. PC Van Vliet. I will be adding it today. I promise.
So yeah. So when we put up from here forward, we're trying to put all the models on printables and just kind of tie that back in for the people that don't necessarily want to go through and make everything. They'll get those files as we go. So we put the files up for the Saturn V rocket and PC Van Fleet.
I missed a file. I'm sorry. I will be
we missed
adding
letter A, and we have 2 STLs of letter U. Sorry about that.
I will be remaking that today. I promise.
Yeah.
Anyway, this is going off of. Oh, I actually don't want. I don't want to be going over these. We'll be going over it later.
Yeah.
This is also one of my projects. We'll be going over that later as well. This is also mine. This is Dorian's booth from Open Source. Can you really quickly shout out Dorian?
Big shout out. So Dorian,
to us.
It's so fun. So we've shouted him out a handful of times, and every time I do it, so this funny thing happens, Jake, where I forget that we're literally talking to the world when we're on this podcast, because I feel we're just having a conversation with the community and the people that show up live.
Yeah.
But then people come and they watch it, and they end up messaging me or saying something to me that reminds me that people can watch this. It's the silliest thing, right? I should know in my head that people are listening outside of just the live people, but I don't.
Yeah.
So Dorian is one of those folks. So Dorian went through the Roseville Rising program. We've shouted him out a handful of times. And he just got the itch to make a guitar one week. So he reposted his guitar, which he had posted a while ago. He had this LED guitar. We shouted him out for open source because everybody was playing this guitar. But this is the photo of this guitar. Absolutely amazing. Has LED lights built in. A lot of people that sat down and played it just loved it. Shout out once again, Dorian, doing amazing work. He also took the Fusion certification exam. So when you listen to this, Dorian, if you listen to this, Dorian, reach out to me because I have questions for you about that exam. There is maybe some stuff coming down the line one day where we will help people pass that certification exam.
We've got some behind the scenes stuff going on.
Huge shout out to you, Dorian. Once again, amazing work. You rock. This is the BattleBots booth as well. He's working on some BattleBots. We'll have questions for you there. We have lots of questions for you. And he also
I think we should have him on the pod sometime soon. I think
we should have him on the pod. Actually, we should absolutely have him on the pod. He'd be really fun to chat with. And he also came to the final showcase for our SAC Innovation program. Which was some really cool stuff. So
yeah. Dude, making an electric guitar has been on my list of stuff to make since, I can actually tell you, since 2016. It has been on my list for almost a decade. When I first, at Josh and I's old shop, they had a massive CNC machine. I'd never used a CNC machine. And the person that was using it as I was getting the tour back in 2016, they were just cutting an electric guitar. I said, "Oh my God, that's so cool. How are you doing that?" And he kind of looked at me and he went, "Oh, it's really easy. Just glue some bits of wood together, make sure it's kind of lightweight. And then it cuts out this profile, gouges out the inner, drill some holes, and then you're done." It took me half an hour to make the whole thing. And it was completely blown away. And I remember writing down on my phone, "Make an electric guitar body." I don't know how to play the guitar. I've never played the guitar in my entire life well. And it has been on my list for so long. And now that we are kind of designing booths for different conventions that we go to, I want to have a guitar like this. Yes. And the actual kit that goes into it, like the fretboard, scratch board, neck, and all the electric.
Yeah, you can tell we are not musicians. We are very much not musicians.
Yeah. It's not mind-blowingly expensive. Like the actual body itself is obviously this kind of coveted, beautiful wooden thing that's shellacked and shiny and colored and kind of the wow piece. But the actual rest of it, the guts and the electronics, is not ridiculously expensive. I think it's like $80.
Andy says neck equal fretboard.
Yeah.
Corrections in the chat, please. Yeah.
I was a drummer when I was a kid. I completely recognize I don't know anything about guitars. I kind of know how they work, and that's about it. I will pretend to talk about it at length. And I don't know if you guys can see, but this is all a 3D printed frame that he posted it ages ago. And I love it. And I've been wanting to make one for so long. And this is one of the things that I shall be making soon. But the biggest challenge that I have is that like this wouldn't really fit kind of obviously on like a normal hobby printer. Like I've got an MK4, an Ender 3v3. It's just a normal like 250 millimeter cube of build volume. It doesn't really fit into that. And I know the design is in my head and I don't know how to cut it up to hide the seams. I don't know. So to be continued. Anyway, moving on. It's from Connie. We spent the last 3 weeks of vacation in Austria, Liechtenstein, and Czechia with a rental camper. On the first evening, I noticed 2 supports on the table were missing, broken off. So before I returned the camper, I quickly reconstructed and printed a new one in 5 minutes. 15 minutes to print, problem solved. Connie, that is so rad.
Yes.
I will never stop saying this. The small things that people make and the small things people design to fix problems are by a mile the most... I don't even know how to put it. It makes me so happy. It's the most satisfying thing. because all people kind of go, oh, I need to make a huge guitar to impress people. And it's like, well, yeah, for a big show where you're trying to showcase all of it. But the practicals of 3D printing, where you're just fixing something small and with a little, I mean, you could design this fairly simple piece with what? Week 1 worth of CAD knowledge? That's it. 15 minutes to print. This is a simple part. This doesn't require anything special to 3D, or no 3D printing knowledge, really. Chuck it on the build plate, click slice, and it's done.
You can do it.
And it works, and it saves something from being thrown away. It's actually helping the world.
I want to shout out
it's really useful.
I want to shout out Jerry here really quickly. He said, don't hide the seams, incorporate them into a pattern on the face of the guitar. I love that design philosophy, Jerry. I want to double click on that for just a second, because I don't remember the name of it in Japan, but they've got that specific style that I think you always remember the name of. This idea that the imperfections are the perfection, right? I think especially as we move towards a world with more AI and more just this idea that things are more, I would call them a little more sterile, in the sense that they're like there's a sterility, I think, to perfection when things are.
The Japanese term is kintsugi. I'm sure
Kintsugi.
that correctly. Kintsugi. The general concept of
sure, we just butchered that.
Emphasizing.
Sorry to anybody from. You feel free to correct us one day.
Yeah. Emphasizing imperfections, visualizing mends and seams. Lovely.
Yeah, I love it. It's like highlight it, put it. Like make it the focal point. This is the interesting thing, because it tells the story of how it was made, and there's a whole universe inside of that. So I always really love that idea. And also shout out to, I see Andy and Max going back and forth here. Hey Andy, since you're in here, I want to see that design in our Discord. I don't know if you shared it on our Discord or not. If you didn't share your design for your final project for the SAC Innovation Program, put it on the Discord. Anywho, Jake.
I'm going to elaborate on that.
Okay.
It is in woodworking, just as a general example, when I was teaching people how to design their own things and how to make their own projects, and me just being kind of a floating helper, very often beginners or intermediate or advanced people will make a mistake and screw up, cut a little bit too far, take off a little bit too much material. It happens to everyone. That's fine. It's very, very hard to sand a perfectly smooth curve, for example. There's always going to be little imperfections. That's fine. And I would always have, beginners especially, there's a certain amount of anxiety of, oh, it has to be perfect. And every time they would mess up, they would go, Jake, do I have to cut an entire new huge piece of wood from scratch? Do I have to do that? Like, did I just ruin this by doing a little bit of a cut into it? And the perfectionist says, yes, sorry, you screwed up. You should have done a better job. But I think it's a little bit more interesting if you have a slight imperfection, to really push it, because then it becomes a design intent. And you will notice this all over design, not just in logos, but in graphic design as well, is if it's fairly difficult to make two things line up absolutely perfectly, and it's always going to be off a little bit. But if it's off by a lot, then it's like it has intent. It's obviously meant to do it on purpose. But if two things are ever so slightly out of line, then it's like, oh, that's wrong. So if you're ever working on a design or on any media, and something just isn't quite right, or something's just a little bit overdone, push it, because then it looks obvious. It looks like you know what you're doing. And that is a little hack that extends to everywhere in making, not just woodworking, but it extends into 3D printing and CAD design and drawing and everything. So yeah, push the mistake and it becomes
well, and it's tied to another phrase that I used to say all the time to the students in our program, right? Because everybody wanted to make things perfect and right. And so something I always used to say, and I still enjoy saying it, is the enemy of good is better. So there's this point at which you push, and then actually sometimes there is that point of no return where you crack something in half, where you've over sanded to the point where it's no longer functional, where you got so into the process of trying to make it perfect that you forgot to realize that where you were was good enough. So we can sometimes get lost in that idea that and go too far and try to remove the supposed imperfections and kind of ruin the whole thing. So there's an art to figuring out when you're done. And actually, speaking of which, Jake, I think that ties perfectly in together with the topic of our next book, which is, when are we done with the book, by the way? When are we done with actually making edits of this? And we've had discussions about this. So I want to frame this for just a second. So the part of the discussion is, you and I go back and forth. We could spend the next 6 months trying to make every single project have every single step be as perfect as possible, or we could get 95% of the way there and we could publish it in July, and we could just recognize that 5% we're going to miss, and we can lean on all of you all in our community to hopefully gently point out, but also directly point out, hey, you made a mistake on page 96. Hey, this isn't quite what I thought. This is confusing. And so, Jake, we have to figure out what is 95% done so that we can actually push this thing out, so that we don't spend another year trying to publish this revision.
And I am not completely opposite, but I'm on the opposite spectrum. And that is, I want it to be as good as possible. Obviously, it's never going to be perfect. And we're just in the age that we live in, we're able to publish something, make some tweaks, some changes, and edit, a typo here and there, and then republish it, and then everything's grand. So just for everyone in our community, obviously, if you bought the first book, thank you so much. We're incredibly grateful. You do not need to buy the second book. Absolutely not. There are new projects, but we give away the PDF completely for free. So you don't need to buy the new book. That's completely fine. What I would say is, on top of all of the new projects that are coming in, every single one of the previous projects has some changes in there. Some of them are small. Some of them are introducing new tools that were added since last year's Fusion. Some of them are simplifying certain design elements that were super annoying that may have stopped you from actually completing it last time. And so if you are still going through some of the program, but you stopped and you're kind of working on your own stuff, I'm going to highly recommend that you just download the free PDF. You don't need to rebuy the book, but re-go through the projects. And I think you will be surprised at how much you learn just by doing it twice, but also with all of the new information coming in, because all the projects are being really knocked up a couple levels. And this is bringing back into it the fact that it's never going to be done in my mind. There's always going to be new tools and new ways to make every single project that a little bit more rad. So so we've been emailing a bunch of YouTubers to say, hey, would you be interested in doing some cross promotion? And I've said, this will be done in July.
It will be done in July. It will be done in July.
And that is
why you're
working.
Is
psychological me going, I will publish it.
I'm gonna do it. And by the way, another big update is that every single photo in the entire book is retaken on your excellent high quality monitor that takes even better screenshots than the first time around. So, and this is something that annoys our audience a little bit. And I don't know about you, but in the Fusion category of other books, it is horrendously annoying when you pull a book out and the photos are pixelated and look bad. So we recognize we didn't get all the photos perfect the first time around. Yes, you can talk. But we recognize we didn't get the photos perfect the first time around. This time, Jake, that will not be the case. They will be
immaculate. Okay. Jake rant? Is it time for a Jake rant?
It's always time for a Jake rant. Is it time for a Jake rant? It's always time for a Jake rant.
I need a away, Jake. Okay. Most people haven't written books, okay? So this bit of information may not be known worldwide, but it is to people that are writing books. And this is a bit of information that I did not know about until we published, okay? When we were writing the first book, Josh was working on a Mac and I was on PC. I've been on PC my entire life. My dad works in IT, so he always had PC. That's just kind of how it goes. Okay. When you take a screenshot on a PC, there is no native photo processing, and there's no native connection between the resolution of your screen. So if you take a picture that is really big, obviously it's going to look pretty good. If you take a screenshot of a really, really small place, it is going to be incredibly pixelated. I think that's a fairly easy concept for people to understand. When you go onto Macs and you take a screenshot of a big thing, it looks exactly the same as it does on a PC. Great. When you take a screenshot of something that big, like the icons on the timeline, on a Mac, it will do a thing called pre-rendering, where it will essentially mathematically recalculate where all the pixels are, and it will artificially bump up the resolution as if that area that you just took a picture of had 10 times the resolution. So all of the tiny pixels that make up the extrude icon in the timeline, the one that's absolutely tiny, it's what, maybe it's less than 100 by 100 pixels. It's pretty damn small. But when you take a screenshot of it on a Mac, it then becomes so much easier to see. And because of that, when we were taking pictures of an operation with the dialog box on the first edition, where it's got all those tiny little bits of text, very hard to read. That is completely our fault. And so for this edition, I am retaking every single photo in the entire book, just under 2,000 photos, and they will all be immaculate and pretty and easy to read.
I see what you did there. Immaculate. I see what you did there.
Yeah, but why is this not a standard?
I don't know. And I mean, so we discovered this to double click on that for a
by
second.
accident.
Because I was taking screenshots on my Mac, but I also have a second monitor, and I was taking some of them on the Mac screen and some of them on the second monitor, and they were not coming out the same. And we didn't discover that for quite a while after launching the book.
Until I think the last step.
This is like, the slogan "Move fast and break things."
Yeah.
Right. Right. That's I don't even know who it was. One of the big tech companies. Well, it's one of the big tech companies that says as well, move fast and break things. That's one of the other reasons I think it's so important to just push, because you don't even know what you're going to discover. Nobody could have coached us, I think, in a reasonable way prior to doing this. We would have had to search for somebody that had the specific expertise. We had to discover it by doing it, right? And so that's another reason I think that launch before you're ready. It's the difference between the SpaceX and the Tesla model, right? Or sorry, SpaceX and NASA. NASA's like, get everything perfect. We're going to spend $100 billion on launching a rocket. It's going to take all this time. We're going to make sure that we launch it perfectly, right? But then SpaceX goes, we're going to recognize that we're going to make some mistakes here, and we're going to go as fast as we possibly can, and we're going to launch 4 before you can even launch 1. And now they've launched hundreds and hundreds and hundreds, and they've really left.
There was one that flew over my house.
That's so amazing.
Last week. That's looks
so amazing,
so rad. It's got all the blue Falcon thrusters coming off the back. It just looks so ridiculously good.
Amazing.
Oh, amazing. I love seeing the rockets. I'm I think like an hour drive away from Hawthorne. Hawthorne, which is I think it's a town or a city. It's a neighborhood. It's very close to Los Angeles, which I'm nowhere near. And that's where SpaceX is, and it's right across the street from Tesla, which is right across the street from Hyperloop, which is right across the street from a Costco. Which is it's like this really weird. It's like this really weird neighborhood. But yeah, really, really funky, weird area. But
back to I Made a Thing, shall we? All right. So showing off what you and our community make, and this is a reminder for those listening in for the first time. Please do join our Discord and share what you make in the I Made a Thing. We are going to be publishing most of those, as many of those as possible in the next book.
Mr. Mitnick, PC Van Vliet, dude, my rocket is right there. I will be putting it up on my wall pretty soon, but I will be updating all the letters today. I love this project, and you obviously printed the entire thing and assembled it correctly, which I was a little hesitant that I'm like, oh gosh, is the design too tricky or too annoying to kind of assemble? But dude, you did it absolutely perfectly. I hope you enjoyed the build. It was really fun to design. I absolutely love it. I also like your Star Wars little.
That's so great.
What is it called? Not terracotta. What's the bloody word for it? The white and blue ceramic. Oh my god, I'm completely forgetting. Anyway, I love this as well. And then one of the things that we didn't get to cover last week, friend got a table, but unfortunately the chairs did not fit. Oh wait, I think we did cover this last week.
I think that's as far as we got. So then, yeah, you can scroll back down. I do think we chatted about that because we talked about the supposed simple solution, like we talk about every week. Design real problems, design solutions for real problems you have in life, and a lot of times those they're easier than you think, especially when you have CAD design skills and a 3D printer.
Yeah,
so amazing.
I want to hijack this and talk about my new project that I've been working on for the last couple of weeks. That was literally printing while we were gone the other week. At the very end of the book, there's a project called Gear Train, and it is based off of an art installation that I saw when I was a kid that I think resides in the University of Wisconsin, I think, or Michigan. And it's essentially a massive electric motor that's running a gear that goes to a worm drive to another gear, worm drive, another gear. And it essentially reduced so much that by the very end of the gear train, the last gear is set in concrete. And it will take the lifespan of the universe to make one revolution. So it is technically moving, but it is completely locked in concrete. And I was viewing at it as a kid as like a mechanical, how amazing is this? I think the whole point of the art installation is the efficacy of time and the standstilledness, but things are actually still in motion. Yada yada.
Standstilledness.
Standstilledness, yeah.
Welcome to the CADclass podcast, where we make up words.
Where we invent a different word every single week. And I always loved it, and I've been meaning to make it for so long. And so I'll be publishing the video fairly soon. But I decided to flipping make it. This is my gear train. It is made up of 28 5-to-1 gears. I don't know if you guys can see the very, very small gear at the bottom there. That is being run by a 2500 RPM little motor. You can see it kind of whizzing around, but it will slowly get reduced a 5th, 25th, 125th scale all the way down. And as you can see on the top, if it'll get in focus, there we go. All the back ones are actually still in place, and as you get closer and closer and closer, they're more and more out of whack. And I absolutely love this thing. But we're showing off the exponentiality.
Let's just keep making words. Exponentiality.
The exponentialness. You know what I mean. It doesn't matter. Of gear reductions. So this first gear takes 0.02 seconds to make a full revolution. And so it gets fifth down more and more and more and more and more. So this gear right here will take a year. Then after 2 gears, it takes a decade. Then after another gear, it takes a century, then a millennium, then a million years, then 1 billion years. Then this last gear will take 14 billion years to make a full revolution. I love this thing so much. I think it's one of the biggest 3D prints I've ever done. And it's quite big, and we're going to be taking it to some trade shows because I absolutely love it. But dude, this was such a fun build to do. I'm like so stoked at the sheer scale of this thing. It is such a beast. I love it.
I love it. I love this playing around with the concept of time as well, because it is, especially when you think about these gears spinning, it does really force you to remember just how vast, this scale of things, right? It makes, for some reason, seeing that last one and hearing that it takes more than the length of time the universe has existed to turn one revolution, right? And it fits on my desk. It just makes me think about time and space and our place in it all, and how small and frankly insignificant we are. Little specks of dust. What is the Carl Sagan? We're but speck of dust on a. I can't remember how we're a
blue marble of dust floating in the abyss.
Whatever it is.
Something.
Yeah. Shout out to Carl Sagan if you haven't watched his take on the universe.
I know he's been dead for a couple decades, but shout out Carl Sagan.
What up, Carl?
Oh my god.
All right, we got some more stuff to show off in there.
We also do. We have another thing that you've been playing around that I've wanted you to kind of show off for a little bit, that I think you have behind the scenes.
And this is
Josh.
Yep.
This is not your project. This is by Ogre. But
yes.
Got my A1 combo and been playing around with Leonardo A1 to generate these pictures, and then HForge. God, that looks absolutely amazing.
So HForge, let's go ahead and introduce HForge. So shout out to you, Ogre. That's amazing. I really love that work that you just did. I've got my HForge print next to me, but HForge is a piece of software that essentially allows you to paint with filament, and you can swap. You don't necessarily have to have a 3D printer that has a filament changer. You can do that manually. You can build it into the slicing. You walk through and do all of that, right? But one of the big things that happens is you can generate AI images extremely easily now. Obviously, with all these new AI tools, you can take those images into this software called HForge, and then using HForge, you can drag and drop colors into it and paint with it. And you can see in real time what it's going to do, or you can see what it should do. And now I think Ogre mentioned some of the issues he's having. I actually reached out to somebody that is close to the HForge team. I don't know if he's on the team. He might be on the team. I think he calls himself a bug smasher. So he's trying to figure out and fix all the software bugs. But he was at Open Source and he was showing off some of his projects. And you and I were both really blown away by the quality of the prints coming out, and also by the tactile feel of them. It's like you pick it up and it's not quite an image, obviously, right? It's not printed on a piece of photo paper. It's got some three-dimensionality to it. Let's go ahead and keep making it. Yeah. So it's got some three-dimensional nature to it, and it looks incredible, and it feels incredible. And so it got me thinking about using the software. So I went on, I generated some images with Dolly, and I have in the Discord there, as well as here in person, one of those images, which is this 3D printed lion, which I just started to paint. It's just 3 color. I wanted to keep it fairly simple for now. And I got to say, I have so many ideas about how people can bring their creativity to life that is not just the normal mechanical nature of 3D printing that we talk about, but really artistic. And so, thinking about how to use these machines, not just for engineering programs, but for everybody. Like, this is something you could reasonably do at home. Generating images is not hard. Painting on them with the software is not hard. Once you slice it up, basically the printer does everything for you. It stops, it tells you when to change the filament.
And this is not just like a lithophane.
This is not a lithophane. This is layered. And so the way that it prints, it doesn't print one layer at a time. It will print all of one color's layers at once, and then it will go back down in height and print some more and print some more. And so if you were to try to paint like this with the typical softwares, it doesn't give you even close to an accurate representation of what it will look like. So you could technically kind of do this inside of Bamboo Slicer, Prusa, right? But it doesn't actually reflect what it will look like when it comes out.
I've seen it work. I think someone posted a video where they did the PlayStation logo. It's the N. It's like on 4 sides, where it's all just primary colors and there's very harsh edges to it, and it prints really well and it looks fantastic. But the images that we saw at open source, I couldn't actually tell that they were 3D printed until I was about that far away from it. They were actually very realistic photos, but they only took like 4 or 5 or 6 colors to make it. Obviously, if you show your picture again, Josh, it's obviously kind of psychedelic color range, where it's got the black and the blue and the yellow. It's not a realistic photo. The pictures that they had were like a green pathway on a forest, or a butterfly that had a couple psychedelic colors, or they had different animals, or they had a lion's mane that was in a few different shades of orange and white, and they looked hyper realistic. They looked like a normal picture, but I would have completely walked past it, and unless I hadn't seen that they were actually printing one out there. And it doesn't look 3D printed texture-wise, even when you're holding it this far, and then it's only until you kind of look at an angle that you can see there's any height. I mean, you said there's like 16 layers on it. It's nothing. It's pretty damn thin. Yeah. And it just looks it looks amazing. It looks unreal. And
it's incredible. It's a lot of fun.
From where we went, from where we were, 5 years ago in the 3D printing world, this is it's ridiculously cool.
Yeah. Yeah, and so it's a painting software, and so so PC Fanfleet says, I think of it as actual paint. If you paint with red over blue, you get purple, and that's what HForge does. Yeah, they measure the luminance of these colors as well, and so they've got a bunch of pre-built settings so that you can measure that, and then it calculates using the software how much light will transmit through it, and therefore how much of it to lay down layer by layer.
And then they actually had a little color tester as well.
They did
while they were there, so you can literally put in a bit of filament, and then it analyzes the hex code or the RGB or anything like that, and it will actually give you all these values. I'm like, this is such an amazing setup. And apparently a lot of people walking by going, is this open source? Is it free? And they were saying, no. I think it's like $18.
$18. I paid $18 for a personal license. I don't plan to sell any of these prints. I just wanted to show it off. So totally fine for me and for my purposes. So $18 feels like nothing. And by the way, they have a really nice collaboration with Polymaker. So what happens when you spend $18 on the software is they give you an $18 coupon for Polymaker. So I can just go get filament. So if you're going to buy filament anyway, you may as well check out Polymaker. Shout out to Polymaker, and shout out, by the way, to Sean, the 3D print general, who now works with Polymaker. They did him a huge solid, and I mean, he's an asset to their company as well, so I'm sure it goes both ways. But when everything was going down with him on YouTube, they brought him in basically right away. First, they said, we'll sponsor your whole channel. We'll make up all the lost ad revenue because he got his monetization cut. And then YouTube completely banned him, and they hired him. They brought him in. So shout out to Polymaker. It seems like you're doing really good work. Shout out to our friend Sean. And if you do end up purchasing HForge, just know that all that money you can use to buy filament. So it's basically like, it's kind of like you got the software for free, because I'm going to buy an $18 roll of filament that I would have bought anyway, and go from there.
All right, Josh. I want to go on to a different topic. Prusa just came out with a brand new printer yesterday, and you've done a little bit of information on it. And I've done not information research about the actual printer, but I've gone on to every single Reddit post that I've seen about it and read all the comments and all the discussion on it. So it's called is it the HT60?
It's the Pro HT90.
HT90, thank you.
The Pro HT90.
So this is a new printer by Prusa, and it is right at the very top. It is not for us. I'm almost positive it's not for anybody watching this live, or not for anyone.
It's more for professionals. This is their professional line. So the Pro HT90. Do you want me to give you a couple of details on it, and then we'll launch into what it is and how we think it fits into the ecosystem? So it's called the Pro HT90. And back in 2021, Prusa acquired TriLab. So TriLab was working on a Delta kinematic printer. I didn't even really understand what Delta kinematic was. I had to do a little research on that. Do you know what Delta kinematic is?
So I know what Delta is. So Delta is instead of having an X, Y, and Z coordinate system, you have 3 vertical arms, and as one or all of them move up or down, then the head can move left, right, front, back, up, and down.
Good. So it's not a Cartesian-based system. It is a completely different, but it can still be sliced by the same softwares. And these, instead of being vertical, are actually angled. So they're at angles, and then you have multiple moving parts. So this is it's a new style of printing. It goes, the print head is attached to these 3 arms that kind of move in tandem, right? So it's a completely different style than especially the bed slingers. And Sam says it's 9,990-ish, but it looks really great. Exactly, it's aimed at professionals. So Prusa acquired TriLab back in 2021, and apparently they've been working on this professional grade printer since then to get it kind of where it is in its current state to be able to launch it. Pro HT90, it's super high temperature. They claim it can do a kilogram of PETG in 8 hours. An entire kilogram of filament in 8 hours, which is that's cooking.
One of the people they interviewed in the video they published said, "Oh, we had a Prusa Mark IV, and they said what we could do print in 24 hours on that printer can print in 8 hours on this one." And they attributed that to the fact that it has, I think they didn't say the word larger nozzle, but they said like an extreme flow rate and extreme speed.
Yeah, so it's quick.
It's a quick machine.
It's a quick printer. It does, and it also gets, so the nozzle gets up to 500 C, which is smoking. That is very hot, and it is aimed at doing a lot of those professional, like PEEK, PEKK, a lot of these crazier materials. I thought about pulling the material names up, Jake, and just seeing. One of my favorite parts of one of the videos you made was that it was almost a blooper bit where you tried to pronounce.
Oh, I still can't pronounce ABS properly.
I thought it was PETG you were trying to pronounce.
Oh, I don't know.
Whatever it was. I thought about pulling up the chemical names of these and just going, "Hey Jake, what does this say?
Try and pronounce this."
Yeah, can you read this for me? Can you actually read, Jake? Let's see.
It's not my first language.
I know you can write, but can you read? Exactly. So it gets up to 500 C, prints a kilogram every 8 hours. It's aimed at professionals. It's kind of a different thing here. And Jake, I think the interesting thing about this is really what it means for Prusa, because there's been a lot of talk about Prusa and being able to compete with Bamboo. And to be honest, I think Bamboo is winning in the direct-to-consumer market right now. I think there's more hype and there's more people getting into 3D printing using the Bamboo. And this is just a guess. I could be totally wrong. Maybe somebody from the Prusa team will reach out and tell us how wrong we are, or, I'd be super curious to know. But from what I can tell, and most of the conversations that I hear, people are getting into 3D printing and they're starting with the Bamboo. And so we've been talking quite a bit about what that means for Prusa. Does that mean that Prusa is no longer this, this dominant in this market? Where do they go from here? What's next? And it seems to me, Jake, that maybe what they're doing is moving up that value ladder, that they're recognizing that as 3D printing is taking off and more and more people are learning it, that the need for professional grade 3D printers is also going up. So I actually think this is quite a good move for them. The parts are injection molded. They're not actually printed on, as far as I can tell, most of the parts are not printed on 3D printers.
No.
It's an injection molded final polished product. And I think it's a pretty solid move for them. I think it is about the right time to start thinking about, if you're a company in this space, how do we serve engineering teams better? How do we serve, medical offices better? How do we serve, right? How do we serve that client that's slightly higher up the value ladder? That's my take. What's your take? Yeah.
So the price that it doesn't say on the website, but people have dug in a little bit and they found that it's a hair over $10,000. Obviously, a lot of people are going, "This is ridiculously expensive. That's so absurd. I can get carbon for half that price." Blah 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 blah. It's like, it is not for you. It's for a different clientele.
Yep.
The clientele that they're going towards, $10,000 is nothing. It is absurdly inexpensive. The people that are going to be using these printers, they're more used to working on $100,000 machines
or $500,000 machines,
because they are so niche
expensive
that the manufacturers need to price it at such a high point, just because they're not selling as many. And because Prusa already has that base, that means that they can offset some of those costs and they can produce it as small. Fantastic. What this is kind of reminding me of is when Apple released one of their monitors a few years ago. So they released something, I think it's called the Pro XDR. It's just a monitor. If you remember the meme a few years ago where they're selling a monitor stand for $1,000 and people were laughing, going, "That's absurd." And then people looked at the monitor and they went, "The monitor is like $6,000? Huh? What?" And the market that they were putting in was not to consumer. It was to professional animators, people that edit movies, that work on CGI, where those monitors that are half the size are easily $15,000, $20,000, purely because they're incredibly accurate monitors. And so it's like, yeah, it seems unreal, a stupid cost from the consumer, but for the audience that it's actually going to, it's a steal. It is such a steal. And so I'm looking at Prusa and I go, I have loved their printers for so long. I've coveted them since I was in high school when I first wanted to get into 3D printing. And the idea of them going, "Oh, we can't deal with Bamboo because they're just crushing the market," that it does make me a little sad, because I don't want to see.
I think they can deal with Bamboo. I'm very curious to see. I think they can still continue to compete at the bottom end of the value ladder, but I'm curious to see how.
And so if this is then coming off as we're getting all three sides of the market. We're getting the really high quality middle ground. We can also get the more inexpensive 3D printers, the reality world, as well as the high level industrial. Dude, hats off to them. Good luck.
Yeah. Good work. Good work, team. Yeah, I can't wait to see what continues to come out. I have a feeling that it's going to be a busy summer of launches. We're going to see a lot of which also makes me think, Jake, I did something a little different, which was I went deeper and did a lot of research this morning about the Prusa, and then I actually went into 3D printing news and CAD news, and I started to realize that I both enjoyed the process and learned something new, and that I would like to start sharing that with our audience. So I'm going to have a segment I'm hoping here in the next coming weeks that I start to develop, which is just going to be news in the industry, like industry style news. So whether it's CAD,
that's what we're going to call this segment. We're going to call the segment news.
That's exactly what you want. Hype, whatever it happens to be. But I want to talk a little bit about what's happening, what's changing, and why, and how it relates to you all in the audience. Hopefully just up the learning that happens during this just a little bit, and for myself, for my own purposes as well. So more of that coming down the line.
I think we should switch gear. Oh,
I have a gear to switch to, because
I think they're the same
a handful of people are here right now from the Sierra Service Project, SSP, and we are launching our brand new innovation program along with Max, who I saw in here, and whoever else is in here, you feel free to say hello. But along with Max, Max is the program director over there, and he's doing absolutely incredible work with them. We've teamed up. We're going to be teaching these kids how to use a Bamboo A1 Mini. So I'm going to go here as soon as this podcast is over. I'm going to go straight over to CADclass and start working with all of them. So they're going to learn to use the A1 Mini, and we're going to run a plant. Let's go, Max says. Let's go, Stack Sustainability. I'm going to go ahead and post that comment. So Max Rosa, huge shout out to you. Amazing work, my friend. He's building the minis right now. He couldn't even wait for me. So that's okay though. That's okay. They're so easy to build. It's kind of impressive how easy they are to build. It's 10 minutes, 15 minutes. You're set up. You're printing a benchy. I'm guessing that by the time I get there, they're going to have their benchies going, and he's going to be like, ha, 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 we're already doing it. What I want to say, and this is a shout out to all of you in our audience, you are welcome to join along for the ride. We are going to be focusing on innovation in plants, urban agriculture, and that sort of general space. So this program is going to be focused exclusively on, most likely we're going to do hydroponics towers. So Jake, this brings me to something that we designed that kind of was the start of our company. And it was a very early on design. We had been talking to somebody that worked at Matter Hackers, and he had told us that his friend was making a bunch of money selling moss poles. We're like, what the heck is a moss pole?
Can I take over from here?
Yes.
All right. So we were getting into so originally our company was a 3D printing manufacturing, a print farm essentially, and playing around with a couple of products that we made that we were selling online. A couple change here, great. And one of our friends said, "Oh yeah, one of my buddies has a business, and he literally cannot print fast enough. He's buying so many new printers that he doesn't have room, and he's asking me if I know anyone that has multiple printers that he can essentially use and pay us to then offload." And we're going like, "Yeah, how much is he making?" And he goes, "He's selling $5,000 worth of product per week as his side gig. This is not his main job." And we're like, "Oh my god, that's amazing! That's fantastic. Yeah, we can absolutely help." And he was going, "Oh, what different things does he sell?" And he goes, "Oh, he sells moss poles." What's a moss pole? And he goes, "Oh, it's like this little cylinder that you screw into, and it's got a bunch of holes in it, and you put moss in it, and plants can grab onto it. It's like a good structure for them to grow tall." That's it. And I was like, "Can I see the design?" And he's like, yeah. It's just a plastic tube. Like, that's it. It just had holes in it. And I'm like, "Who is buying this?" And he's like, "You have no idea how many people are buying it."
The plant people.
The plant people.
The plant people are
and
buying
I'm like,
it.
"Vegans?" And he went, "No." And he said, and he goes to all of these plant conventions. And he's going to all these conventions all about plants and gardening and agriculture and this and that, basically every single weekend. And he's like, "I physically cannot, I don't have enough space. I don't have enough outlets in my apartment to print these moss poles fast enough." I'm like, "That's a kick-ass problem to have. That's fantastic." And so we thought, let's make our own design that's totally different from his, and let's see if we can do it. And we made 3 really rad designs. They were all interchangeable, interlockable, super fun to design. And
yeah,
little green screw mechanism.
I love this, right? So this, and we used exactly the design principles. It's hard to, I can't figure out which way I'm turning this looking at the camera. That's funny. I'm like, can you see it? Can you see it? Can you guys see? No. But this conical screw cap mechanism right here, it's just so elegant. I love it. And then the end cap here, which is different for each one. And then obviously this middle portion here. And Jake, it's designed to be modular.
Yeah.
So you can just screw together more and more pieces because as your plant grows, right? And so this is where the idea of hydroponic tower also came in. It's like, hey, we can use these same design ideas to design and build hydroponics towers, and they can be
Can you explain
expandable.
What hydroponics is to people?
So hydroponics, and I still don't know a ton about it, but what I can say is that basically hydroponics, as it pertains to towers, hydroponic towers, are vertical grow towers where you put the plant and root system inside of a cup, and they're all slotted into the sides of this, and then you filter water and nutrients over the top, and you kind of spread that, and it just trickles down over the top. So over time, these plants are getting water and nutrients directly on their roots. There's no soil involved, flows through, I think. and Max, I'm sure will let me know. So it is a soilless medium. So the water trickles down from the top along with the nutrients, and then your plants grow, and they are incredibly efficient. They take up very little space, and frankly, the ones that are designed well are really beautiful. And I have a friend that had one, and his whole, like, you walk into his apartment and he had some LED lights and all these beautiful edible plants. And so he had all of his herbs and spices, or rather all of his herbs, just growing out of this hydroponic tower. So we're going to make a hydroponic tower out of these expandable. We want to make it kind of artsy and completely functional. And we're going to use these design concepts to make it so that you can have a couple things in the beginning and then maybe build it out and expand it as you go. Maybe it's a collector set. Who knows? I say we're going to be doing these things because this is the innovation program that's going to be working on a lot of these things. And we don't really know what ideas they're going to come up with, but it's pretty exciting. I think they'll be amazing.
And this is a project that I've wanted to do for years.
And so Max says a lot of these kits sell for over $500. So they're inaccessible, right? And it's nothing more than a water pump with a reservoir and some cups put in a tower. It's really not hard. And you don't have to add, and you don't even need PVC. Like I'm going to try not to use PVC. I've started to kind of dislike plastic touching my food for all the studies coming out with plastic and the problem that we're having with it accumulating in our bodies. I won't go into detail, but it's not great. It's not.
We all know what's going
on. But the idea is to make it simpler, cleaner, cheaper, more designy, more beautiful, and make it accessible to people that want to grow their own food at home. So
when I first heard about this project on a video essay years and years ago, where it was something like, how did ancient Egyptians that had this huge civilization but in the middle of the desert, how did they get their food? And one of the proposed options was, they use an aquaponic system or hydroponic system. And the idea is so groovy that it's essentially a recirculating system where they have a trough of water that has some fish in it, and they will feed food to the fish. The fish will eat it. They will poo it out. That has a bunch of nitrogen and vitamins and stuff the plants need to grow. That then, all that water, the pooey water, then essentially goes into soilless water, where it just has rocks and gravel and plants that can then get all those nutrients and grow, and it essentially pulls out all of the horrible stuff. And then as it goes down, it's getting filtered. All the food that comes off of there is using a tiny amount of water. It doesn't actually stay there very long to then get evaporated, so it's just continually going around. And then as it's very done, it is falling off essentially a waterfall that's getting pumped. So then the water is getting aerated, and then it's splashing back into there, and the fish then can breathe very, very happily. So it is this very cool kind of self-contained unit, and it's such a groovy idea, and I've been wanting to do it for ages. Cody's lab made a video about it years ago, and he did it with some goldfish, and he made these gigantic heads of lettuce, and it was amazing. It was absolutely fantastic.
Amazing.
And I've wanted to make one for years. So this very well may be it's going to be come up with a rad design. I think it'll be the kicker for me to make one.
I'm definitely going to make one because I wanted to grow my own herbs at home anyway. And frankly, I can't believe I haven't bought one yet. They're great. So I'm like, why buy it when I can make it? So I'm definitely going to make one. And this is what I wanted to involve the community with. So just because you're not here in Sacramento and running through this program doesn't mean you can't participate. So I would love to see some of your designs on aquaponics. If you make a little aquaponics tower, they're completely accessible with 3D printers. Again, you don't need much. You need a reservoir with a water pump. And if it's a small system, that water pump does not need to be very strong. You have to do a little bit of research on water pumps. Pump the water up to the top, design the little cups that go in the sides, and that's it. It's not a very complex project. So to our community, I would love over the next 8 weeks, that's how long this program is, to see your hydroponic tower designs. We will share what we make along the way. And let's go.
See what we do.
Let's see what happens.
I'm really excited.
Let's grow some food.
Yeah. And it's that is very true, PC Van. Yeah.
Jake, I think that's the pod.
I think it's gonna be it. I need to get back. I actually need to write a book.
I think you have work to do. Yeah. So new book coming out in July.
It's coming out in July.
Spread the word. Coming out in July. Yeah.
All right, guys.
It's been fun.
We'll see you next week.
This has been the CADclass podcast. Once again, I'm Josh.
I'm Jake.
And
see you later. Peace, guys.